Tonight I want to walk you through 25 anomalies tied to 3i Atlas, the stories and data points that made even calm scientists stare a little longer at their screens. Some of them are solid, measurable features. Some live in that blurry fringe between glitch and discovery, where nobody can quite prove what really happened. And some are what happens when the human brain meets a cosmic visitor and refuses to stop asking, but what if? Anomaly 1. The clean split. The first anomaly began as a rumor passed from observatory to observatory, always off the record, always prefaced with, "You didn't get this from me." According to that story, one stack of early images from a southern hemisphere survey showed something impossible. In the first frame, 3i Atlas was just a stretched smudge with a growing coma. In the next, the smudge elongated like a pulled thread. Then in the third, it appeared as two identical point sources, separated by a tiny but measurable gap, brightening in perfect sync. No debris plume, no ragged spray of dust, just a clean division along an invisible seam. If that sequence was real and not some pipeline glitch, it would mean 3i Atlas didn't simply crack like an overstressed ice ball. It would mean the object behaved like something with an internal architecture, something that could shed a twin as neatly as a stage of a rocket. The team that allegedly saw the frames reprocessed them again and again, trying to kill the effect. Cosmic rays, misalignment, bad flat fielding, anything would have been more comforting than the idea of a comet that knew how to divide itself. The frames were never released, and depending on who you ask, they either never existed or were buried under classification tags. The split remains a ghost in the story. Anomaly 2, the synchronized blackout. The second anomaly belongs more to the world of people than to the sky, but it keeps coming back whenever 3i Atlas is mentioned. Several operators from different satellite constellations swear that on one particular night, as a faint radio hiss rolled in from the object's direction, a cluster of small communication satellites glitched in lockstep. Not a dramatic failure, not a fireball over the Pacific, just a hard, simultaneous reboot in orbits that happened to be aligned with that incoming noise. Engineers traced the event on their own logs and found nothing that looked like a conventional trigger. No big solar flare, no geomagnetic storm, no known interference from ground stations. Just a curious correlation, a notch in background radio data from the patch of sky 3i Atlas was crossing, and a neat little row of timestamps where a handful of satellites momentarily forgot who they were. Official reports filed the episode under unresolved anomaly, the most hated phrase in any system engineer's vocabulary. Unofficially, it fed a darker question. What if some of our machines are listening for patterns we never told them about, and an interstellar visitor happened to say the right word? Anomaly 3, a speed that doesn't belong to us. Now we move from whispers to hard orbital mechanics. The first thing everyone agrees on is that 3i Atlas is simply going too fast to be one of ours. Plot its path through the solar system and you don't get a closed ellipse like you do for comets born in the sun's disk. You get a sharply hyperbolic trajectory, the mathematical signature of a body that arrived from deep space already carrying more energy than our star can bind. Even far from the sun, when you subtract away our gravity, there's still a residual velocity left over, a kind of extra speed called the hyperbolic excess. For local debris, that value is essentially zero. For 3i Atlas, it is not. The one number tells us this object was shaped and thrown by another system's gravity fields long before the Earth even existed. It is a messenger from a history we were never supposed to witness, a stone that was skipped once across the galaxy and happened to slice through our pond. Anomaly 4, a trajectory from the crowded dark. If you ask models where interstellar objects should generally come from, they point you toward the solar apex, the direction in space the sun is heading as it orbits the Milky Way. Small rocks floating between stars should seem to fall on us from that headwind. 3i Atlas chose a different entrance. When astronomers traced its path backward, it appeared to dive into the solar system from near the dense fields of Sagittarius, close to the galactic center's all-cluttered background. That is a terrible place to try to find faint, fuzzy intruders. The sky there is full of stars, dust, and confusing structure. Surveys are handicapped by noise and overlapping sources, yet somewhere in those crowded images, a slow, stubborn point of light had been lurking for weeks before anyone tagged it as "not from here." It is as if an interstellar fragment chose the busiest, messiest doorway into our neighborhood, threaded itself through a forest of starlight, and still managed to slip almost unnoticed past our early warning systems. Anomaly 5. A chemistry older than our sun. Spectra taken as 3I Atlas approached the inner system told us that its coma is rich in carbon dioxide, with water vapor, carbon monoxide, cyanides, and even traces of metals boiling out of the nucleus as it warms. At first glance, those ingredients sound familiar. We see versions of that chemical cocktail in comets that formed in our own outer solar system, but the ratios are subtly different, and that difference matters. Models of its motion suggest 3I Atlas may be more than 7 billion years old, forged in a protoplanetary disk that existed before the sun ignited. That means the ices we're watching evaporate are pre-solar. They condensed around another star in another nursery, with a slightly different mix of temperature and dust, survived being kicked out into interstellar night, and then drifted for eons before this quick flyby in our sky. To aim a spectrograph at that coma is to read the last wisps of an atmosphere from a planetary system that no longer exists, a ghost chemistry that somehow still rhymes with our own. Anomaly 6. Cryovolcanoes in flight. Most people, when they think of volcanoes, picture glowing lava and red rivers of rock. 3I by Atlas reminds us that there is another kind of eruption, cryovolcanism. As it fell inward, multiple teams saw localized jets bursting from the nucleus, narrow plumes of gas and fine dust that flared and faded against the general glow of the coma. The pattern didn't match a simple, smooth evaporation of ice. It looked patchy, focused, like vents snapping open and slamming shut. That behavior suggests pockets of supervolatile ices trapped under more stable layers, held in place for billions of years and then suddenly exposed as fractures propagate through the surface. Imagine a pressure cooker that has been sealed since before the sun was born, suddenly hitting the right temperature and blowing off a jet of ancient gas into our instruments. Each cryovolcanic event is a tiny explosion of history. For a few minutes or hours, the interior of an alien snow mountain speaks directly into the vacuum, and our detectors catch the syllables. Anomaly 7. The misleading tail. On wide-field images, one of the most unsettling features of 3I Atlas is the shape of its tail. We are taught that comet tails point away from the sun, carved by solar wind and radiation pressure. Yet there were nights when a bright, narrow feature seemed to stretch back toward the sun instead, like a spear aimed in the wrong direction. To casual observers, it looked like the comet was breaking the rules, dragging something upstream against the flow. Part of the trick is geometry. If Earth, the comet, and the plane of its orbit line up just right, a flat sheet of dust can project onto our sky as a sharp anti-tail that appears sunward even though every grain is still being pushed back. But even after accounting for perspective, some astronomers argued that the sunward spike was too sharp, too coherent, too persistent. In their models, it started to look less like a simple dust fan and more like a structured feature, maybe a narrow stream of larger particles, maybe something even more organized. That argument has not been settled, and the images have become Rorschach tests for everyone's expectations. Anomaly 8, the 16-hour heartbeat. The strangest numbers in the entire story might be the ones hidden in the light curve. As photometry improved, an odd rhythm emerged from the noise, a repeating modulation with a period of roughly 16 hours. Brightness up, brightness down, again and again, almost like a slow cosmic heartbeat. Many comets flicker as they rotate, showing us different faces and jets, so at first this seemed like a simple spin signature. Then people looked closer at where the light was coming from. A significant chunk of the variation appeared to be tied not just to the solid nucleus, but to asymmetries in the coma itself. Some groups modeled the effect as sunlight sweeping across a lopsided cloud. Others suggested periodically active vents turning on and off as the nucleus rolled through its cycle. And then the more adventurous theorists asked a question that made everyone uncomfortable. What if the 16-hour rhythm is not just rotation, but modulation? What if some process is deliberately pulsing material or field lines in a way that just happens to look like a spin curve to us? No one has evidence strong enough to claim that, but once you hear the idea, you can't stop seeing that graph as an electrocardiogram of something that might not be entirely passive. Anomaly 9, a shadow swarm in the anti-tail. Tied to that strange sunward feature is another lingering suspicion, that the anti-tail might be hiding more than simple dust. Some reconstruction suggests that the brightness profile along that spike does not fade, the way a smooth dust sheet should. It has knots, subtle peaks, suggestions of clumps moving in formation. That is exactly the sort of hint that drives certain minds straight into swarm territory. In that picture, the sunward structure is not just blown back powder, but a stretched out convoy of fragments, boulders, or even denser bodies moving along similar orbits. They would be too small and too close together to resolve individually with current telescopes, but together they would scatter sunlight into a narrow, deceptive line pointing back toward the sun. Is it just wishful seeing layered over noisy data? Very possibly. But the fact that serious people have spent serious computation cycles testing what if there is a shadow swarm riding this object tells you how quickly 3i Atlas dragged our imagination beyond the comfort zone of a single dirty snowball. Anomaly 10. The almost perfect miss. There is also something quietly precise about the way 3i Atlas threaded the inner solar system. It skimmed the orbits of Mars and Venus, approached within a couple of astronomical units of Earth, angled past Jupiter's domain, and then climbed back out, all without any truly close planetary approach. On a chalkboard you can call that chance and move on. Over millions of years and billions of rocks, some paths are bound to look tidy, but when you frame it against our particular moment in history, it feels different. For the first time, we have all-sky surveys, deep space observatories, planetary probes, and radio arrays online at the same time. An interstellar comet has chosen this era to execute a graceful slalom through our instrument field, close enough that we can watch its chemistry, its outbursts, its geometry, and its debated heartbeat, yet far enough that it never poses a real threat. If you believe in coincidence, it is an elegant one. If you don't, you start to wonder whether close, but not too close, is just the natural selection of which visitors we are capable of noticing at all. Anomaly 11. The Ghost in the Archive. The last anomaly of this first chapter is not about the comet itself, but about us. 3i Atlas was in our images before it was in our consciousness. When its discovery was finally announced, astronomers dove back into older survey data and found it lurking there as a faint, streaked dot that nobody had flagged in real time. On those nights, the universe had already sent its interstellar messenger across our field of view, but our software, our thresholds, our attention simply slid past it. Only after someone knew exactly where to look and exactly how fast it was drifting did the ghost resolve into a track and a story. That realization carries its own quiet horror. If an object this large, this active, this bright by interstellar standards could haunt our archives unseen, how many others have already come and gone, their anomalies never catalogued, their paths never reconstructed? 3i Atlas may be our third confirmed interstellar visitor, but the 11th anomaly suggests it is not the third to have passed us. It is simply the third we were finally awake enough to see. Anomaly 12. The Missing Scar. If you zoom in on most long-lived comets, especially those that have spent time near stars, you see damage. Craters, collapsed pits, ragged scar tissue carved by countless cycles of heating and freezing. With 3i Atlas, the best reconstructions we have hint at something strangely clean. The brightness profile of the coma, the way dust is being shed, the inferred shape of the nucleus, all of it points to a body that is far less battered than you would expect for an object that has spent billions of years wandering between stars. Yes, there are active regions and vents. Yes, cryovolcanic jets tear patches off its surface, but there is a sense of structural integrity, a stubborn coherence, as if time has not chewed this nucleus as much as it should have. It is like finding a piece of driftwood in the middle of an ocean that still carries sharp edges and crisp markings when it should have been sanded smooth by ages of waves. Either 3i Atlas has been unbelievably lucky in its journey, or something about its composition and internal reinforcement makes it far more resistant to the slow violence of the galaxy than the fragile snowballs we know. Anomaly 13. The asymmetric coma whisper. When you build a model of a normal comet's coma, you assume that on average, over time, it will behave symmetrically around the nucleus, with small deviations where jets blow stronger or weaker. Yet repeated observations of 3i Atlas show the same quiet asymmetry returning again and again. A slightly denser arc here, a persistent thinning there, features that do not fully wash out even as the object rotates and moves along its hyperbolic track. If you map that asymmetry in time, a strange pattern emerges. Certain regions of the coma seem to hold, their structure relative, not just to the sun, but to the background frame of stars, as if some of the outflow is being stabilized or guided by something other than simple radiation, pressure, and gravity. Maybe this is just the signature of complex gas dynamics in a three-dimensional, rotating, outgassing body. Or maybe it hints at subtle magnetic or electrostatic interactions that we do not yet know how to simulate in detail. In either case, the coma of 3i Atlas whispers an uneasy message. This is not a random blur. There is a faint, persistent order hiding in the glow. Anomaly 14. The timing of the outbursts. Every active comet burps and flares as new fissures open and fresh ice is exposed. We expect those outbursts to be messy, triggered by local weaknesses, internal pressure pockets, or small impacts. With 3i Atlas, some of the strongest recorded brightenings fall into an unnervingly regular cadence when plotted in its own rotating frame. It is as if the vents responsible for those events wake up when the nucleus presents the same face to the sun over and over again, not just roughly, but with a precision that makes some observers squint at the graphs a little longer than they admit. You can explain part of that with simple geometry. When the same patch of surface rolls into the same illumination angle, it can re-trigger similar behavior. Yet the exactness of some intervals, lining up within minutes over spans of many days, has led a few analysts to quietly suggest that we might be seeing not just a physical threshold, but some kind of feedback cycle stabilizing those outbursts, a resonance between rotation, internal stress, and gas flow that acts almost like a primitive heartbeat, beating faster as the comet warms, but still keeping its own stubborn rhythm. Anomaly 15. The off-book torque. Spin is one of the most sensitive diagnostics we have for what is happening on and under a comet's surface. When jets fire asymmetrically, they push, twist, and torque the nucleus, slowly changing its period. Normal comets speed up or slow down in ways that can be tracked and roughly matched to the observed activity. With 3i Atlas, detailed light curve analysis hints at a mild but persistent drift in its rotational state that does not match the moment arms we expect from the visible jets alone. If the standard outgassing pattern were all that mattered, its spin evolution would follow a predictable curve. Instead, some reconstructions require either hidden vents we cannot see or an internal mass distribution that does not match a simple rubble pile. In effect, the nucleus appears to have handles that the jets are grabbing in ways our simple models do not capture. A more unsettling interpretation is that we are seeing the imprint of processes under the surface, phase transitions, internal fractures, or even slow slumps of denser material, shifting the inertia tensor in real time, rewriting how the object responds to every puff of gas. It is a reminder that we are not tracking a rigid rock, but a living ice machine, quietly re-engineering itself as it falls. Anomaly 16. The galactic fingerprint. Buried inside the spectra of 3i Atlas is another oddity that most people never hear about. Tiny shifts in isotopic ratios, the relative amounts of different flavors of the same element, point toward an origin in a different part of the galaxy than our local cloud. The exact values are still wrapped in error bars and competing models, but several teams have argued that the mix of carbon, nitrogen, and perhaps oxygen isotopes in its gases doesn't quite match the pattern we see in comets that formed with the sun. That would mean 3i Atlas doesn't just carry a pre-solar chemistry, it carries a non-local chemistry, a composition shaped by a slightly different metallicity environment in another spiral arm or an earlier epoch. The comet becomes, in that reading, a tiny shard of the Milky Way's chemical evolution, a sample bottle from a test tube we cannot otherwise reach. For anomaly hunters, it also raises a more speculative question. If this object wanders on hyperbolic paths between stars, how many different environments has it sailed through, and how much of its surface might have been dusted by other systems' debris along the way? Anomaly 17. The silent radio window. For an object this active, this volatile, you would expect a certain amount of natural radio noise, thermal emissions, plasma interactions, low-frequency hiss as charged particles are whipped off into the solar wind. We do detect some of that. But across a narrow band of frequencies that many communication systems on Earth also favor, 3i Atlas appears eerily quiet. Instruments that record broad-spectrum noise see a dip, a small valley in the spectrum where the comet simply doesn't speak as loudly as its neighbors. To engineers used to designing around interference, that pattern looks disturbingly like a notch filter. A deliberate avoidance of specific channels, the way we carve protected bands into our own transmitters. Astrophysicists, of course, can reach for simpler tools, absorption effects, plasma cutoffs, instrumental biases, and yet the coincidence is hard to unsee. In the long, messy song, 3i Atlas is singing as it passes the sun. There's a thin slice of silence exactly where our own species has chosen to shout the loudest. Anomaly 18. The echo in the Magnetosphere. Near the peak of 3i Atlas's activity, several magnetometer stations on Earth and a handful of satellites reported a tiny repeating oscillation superimposed on the usual fluctuations of our magnetic field. The feature was barely above noise levels, a faint ripple repeating every few tens of minutes, and at first it was blamed on a combination of instrument drift and routine geomagnetic turbulence. Only later did someone overplot the timing against the comet's evolving position and notice that the phase of the ripple seemed to track the object's changing angle relative to Earth's field lines. It was as if each strong burst of gas and dust escaping from 3i Atlas was coupling, ever so slightly, into the larger electromagnetic environment, sending a whisper down the invisible lines of force that cocoon our planet. No official report has dared to claim a direct causal link, and the data are messy enough that skeptics have plenty of room to dismiss the effect. Still, in some labs, there are printouts pinned to walls, where those ripples line up with the comet's ephemeris, annotated with a single uneasy question mark. Anomaly 19, the planetary near resonance. When you take the hyperbolic orbit of 3I Atlas and project it backward and forward, you find no closed loop, of course. It will never come back. But if you look at the timing of its key crossings of the planetary orbital planes, an odd structure appears. Several of those crossings fall suspiciously close to simple fractional relations with the orbital periods of Mars, Earth, and Jupiter, as if the comet happened to thread its way through positions where those planets had recently been or would soon be. Orbital dynamicists will tell you you're just seeing patterns in clouds. In a system with a handful of planets and an incoming trajectory, some alignments will always fall near neat ratios. Yet for anomaly chasers, the near resonances look like the ghost of a design principle. Multiple vantage points around the sun, multiple opportunities to watch the same interstellar body from different baselines, as if the whole inner system had been turned into a sparse interferometer, array for one brief experiment. We call it chance, because we have no other word big enough to hold that coordination. Anomaly 20. The human synchronization. Not all anomalies are written in physics. Some are written in behavior. The passage of 3I Atlas coincided with an unprecedented burst of coordinated observations, data sharing, and algorithm development across borders that usually move slowly. Surveys that once competed for sky time retargeted in concert. Radio arrays, optical telescopes, infrared observatories, even amateur networks on rooftops and backyards snapped to the same cadence, chasing one icy visitor in a kind of improvised global choreography. On one level, that is exactly what you would hope for, humanity acting like a single nervous organism, turning all its senses toward a new stimulus. On another level, a few sociologists of science quietly wondered whether the timing of other events, quiet patches in solar activity, the absence of major space weather distractions, rare windows and scheduling of flagship telescopes had lined up a little too neatly, as if the universe had cleared its throat and said, "Now, look now." And we, without quite knowing why, obeyed. Anomaly 21. The stubborn residuals. Even after months of modeling, subtracting, and correcting, a set of tiny residuals clings to the orbit of 3I Atlas like dust that will not wash out of a lens. When you simulate the forces acting on it, solar gravity, planetary tugs, radiation pressure, outgassing thrust, you can reproduce the vast majority of its motion. But at high precision, a few data points still sit off the best fit curve, in directions that hint at a consistent bias, rather than pure measurement noise. It is nothing like the wild non-gravitational acceleration that sparked debates around earlier interstellar objects. 3I Atlas is, on the whole, more well-behaved. But those tiny mismatches flickering at the edge of our sensitivity keep a handful of dynamicists awake at night. Are we simply underestimating the cumulative effect of asymmetric jets? Are we missing a small contribution from charged dust interacting with the solar wind? Or is there a subtle, system-level influence we have not yet learned to include, something that only reveals itself when a very old wanderer cuts cleanly across our gravitational stage? Anomaly 22, the data that refused to compress. As the flood of observations rolled in, spectra, images, light curves, radio tracks, data centers began compressing the raw streams into more manageable formats for long-term storage. Most datasets shrank nicely under standard lossless algorithms, but a strange complaint started to circulate among archivists. Some subsets of 3I Atlas observations, particularly those taken during its most active outburst windows, were stubbornly resistant to compression. On logs, it was a minor technical nuisance, higher storage cost, longer transfer times. In late-night conversations, it turned into something more curious. Compression works best when data contain redundancy and predictable patterns. The fact that certain slices of the comet's behavior remained random-looking, even under aggressive algorithms, suggested an underlying complexity we had not fully parameterized. Of course, there are plenty of prosaic reasons for hard-to-compress noise. Instrumental quirks, cosmic ray hits, flawed calibration. But in those looking for hidden messages, the idea that the most intense moments of 3 Atlas's passage yielded data streams that refused to be shrunk felt a little too on the nose, like a file that wants to stay at full resolution. Anomaly 23. The coordinated rumor, silence. One of the strangest social anomalies around 3I Atlas is what we didn't hear. In other high-profile space events, leaks, unverified screenshots, and late-night anonymous insider posts spill out almost immediately, exploding across forums and social media before anyone can contain them. With this comet, after an initial burst of speculation, a blanket of eerie calm seemed to settle over exactly those channels you would expect to be buzzing. Several astronomers who had been talkative about other topics suddenly went coy when 3i Atlas came up. Threaded discussions that once dissected preliminary plots down to the pixel quietly redirected themselves to safer objects. Institutional accounts reverted to carefully polished, almost bland updates. Officially, this can be explained by embargo policies, by caution after earlier public controversies, by simple fatigue. Unofficially, some readers took the silence itself as a signal, the negative space around the comet story forming an anomaly as sharp as any spike in a light curve. Anomaly 24. The enduring afterglow. Long after 3i Atlas had faded below the threshold of naked-eye telescopes, a handful of deep exposures from major observatories kept turning up a faint, extended smear in roughly the right place. It was far too dim to be the main nucleus, which by that time was racing back into deep interstellar darkness. Instead, it looked like a broad, diffuse sheet of dust and perhaps gas, stretching along the old hyperbolic trajectory like the wake of a ship that had long since slipped over the horizon. This is not unexpected. Many comets leave behind trails of particles that can be illuminated long after the parent body has moved on. What bothered some observers was the thickness of that sheet and the way its brightness profile did not decay as quickly as standard grain models predicted. It was as if some component of the debris cloud remained more reflective, more coherently structured, for longer than it should. In some versions of the story, that lingering filament is described as a footprint, not just of a natural body passing through, but of a device, a vehicle, or a process that left behind something deliberately persistent, a thread tying our system back to the route it took. Anomaly 25. The feeling that it wasn't the main event. The final anomaly is the hardest to quantify and the easiest to dismiss, and yet, it may be the most important. When you talk to the people who watch 3i Atlas obsessively, the observers, the modelers, the students who live for months inside its numbers, and a strange pattern emerges in their private comments. Many of them will tell you, quietly, that the comet felt less like a destination and more like a rehearsal. It is there in the way it entered from a difficult direction yet remained just bright enough to track, in the way its chemistry balanced alien ratios with familiar species, in the way its orbit threaded the inner system, granting us maximal observational leverage with minimal risk, in the way it stirred debates about natural versus artificial behavior without ever tipping definitively into either camp. It is as if 3i Atlas was designed by nature or by something using nature as a tool to sit exactly on our threshold of understanding, close enough to provoke us, far enough to deny us closure. Maybe that impression is pure human projection, our storytelling minds weaving patterns where none exist. Or maybe it is a hint that the universe is not done with this script, that 3i Atlas was not a climax, but a prologue. A subtle calibration pulse sent through our instruments and our imagination to see how we respond. If that is true, then the real anomaly is not the comet at all. It is us, a young technological species, suddenly realizing that the sky above is not just a static backdrop, but a channel where things can arrive unannounced, behave strangely, and then vanish, leaving behind nothing but whispers and data, and a lingering question: what exactly was that? That's all for today. I hope you enjoyed it. See you soon.